I'm on. All right, so good old Common Core. A for algebra, RE for reasoning, okay? And it's number 5, which is basically given a system of equations. Okay, and I'll stop there. So a system of equations really means two or more equations, right? Which we have. We've got two equations. So if you have a system of equations, we want to find out what happens. So they're either going to intersect or be parallel, right? So we've got a system of equations, and what we're going to do is we are going to eliminate and solve the system, okay? And that's exactly what we're going to do, okay? So to eliminate means basically we have to get rid of one or the other variable. Now the first example is easy, and I did it. I made it easy on purpose. So if I take a look at the first example, we don't have to do anything. But the whole reason I like this example is because it gives you the impression what we're going to do is add. I mean, we're going to add straight down. And when I see this, I get the 3y and the negative 3y. And if I add straight down, they're gone, right? The y's disappear. So they're eliminated. Now this is a pretty choice problem because we didn't have to do anything to either the y's or the x's. It's perfect. 3y, negative 3y. They're not always like this, but I like these ones. These are pretty sweet. So they cancel, right? And I'm left with a 6x equals 30, right? And now solve for x is really easy. So divide by 6, x is equal to 5, right? Now, of course, we're always trying to find the point of intersection because what we really have is two lines, so we need a y value. So our answer is a point. So what we have is 5 something, right? Our answer is going to point is 5 something. To get this something, let's go back and substitute. Okay, now to find y, substitute. So I can substitute into either the first equation or the second equation. I'll say it again. Either the first or the second. It does not matter. Either the first or the second, it does not matter. But I have to put the 5 in for the x. So, Jackson, which one do you like? The first equation or the second equation?
The first one.
Okay, Jackson likes the first one. I do too because there's no negatives. So Jackson chose the first one. So we are going to take our 2x plus 3y equals 34. And we're going to substitute the 5 in for the x, right? So let's go ahead and finish this up. So we're going to have a 2 times a 5 plus a 3y equals 34, right? Substitute the 5 in for the x. So I've got my 2 times 5 plus 3y equals 34. I'll have a 10 plus a 3y equals 34. Minus 10 minus 10. I'll have a 3y equals a 24. Divide by 3, and y equals 8, right? So my answer is 5, 8. Thumbs up. Does that seem pretty easy? Okay. And you guys did this in Algebra 1, didn't you? Nothing hard about it at all. Okay, now example 2. So example 2 is a little bit like our reading. We're not going to be able to eliminate them at all because they're not opposite. So what I like to do is think about it. If I think about a common denominator, okay, think common denominator. So I could multiply by 3 and 2. I could multiply by 3 and 4. I could cancel the x's or the y's. It does not matter. Cancel the x's or the y's, it doesn't matter. But it seems to me like if I cancel the x's, there's smaller numbers to work with, right? So I can make this as 6x, and I can make this a negative 6x, right? Just simply by multiplying through. So let's multiply the first equation by a negative 3. Multiply the second equation by a 2. When I do that, we'll get opposites, right? And we'll be able to eliminate. Okay, so now let's rewrite these, okay? So let's rewrite equation 1, equation 2. So when you bring the negative 3, bring it all the way through, okay? I'll say it again. Bring the negative 3 all the way through. So I get a negative 6x minus 12y equals negative, positive 30, huh? Almost made a mistake. Bring the 2 all the way through. So I get a 6x plus a 6y equals a negative 6. Okay? Now, I've made my opposites, and if I add them, then they eliminate, right? So add them, eliminate, right? I've got a negative 12y, positive 6y makes a negative 6y equals 30 minus 6 is a 24. How am I doing? Thumbs up. Austin, did I make a mistake?
Never mind. I did it wrong.
That's okay. If I make a mistake, please let me know, because I make mistakes all the time. Yes, I will admit that, even on camera. Okay. Divide by negative 6, and y is equal to negative 4. Okay, so my answer is going to be something negative 4, right? xy, something negative 4. To find the x value, let's plug it in. Let's substitute. Okay, so we need to substitute. All right. Aaron, first or second equation, doesn't matter to me. First it is. Let's take the first equation, plug it in, so we've got a 2x plus a 4y equals negative 10. Let's put my negative 4 in for y, right? So we'll have a 2x plus 4 times negative 4 equals negative 10, right? 2x minus 16 equals negative 10. Plus 16, 2x equals 6. Divide by 2x equals 3. Thumbs up? Seem pretty easy? It should be, because you learned this in algebra, right? I mean, you learned this in Algebra 1, either with Mr. Duffy or with Mr. Bart, right? Easy squeezy? Okay, should we turn the page? Okay. All right, now, you know there's got to be a tricky one in here somewhere. Let's take a look at example 3. Maybe we got something weird going on. All right, what do you think? Okay, Aaron says 3. Let's multiply the bottom by a negative 3, right? So let's see what happens. Okay, so let's rewrite it. So if I rewrite this one, still have a 6x plus a 3y equals negative 12. That's equation 1. Didn't do anything to equation 1, right? Equation 2 now becomes a negative 6x minus 3y equals a positive 12. Now, right, so if everything cancels out, they have to be the same line. Does that make sense? Because it's subtracting from yourself. If you subtract from yourself, then nothing's left. Because you get the 0 equals 0. So if they're the same line, that means they have to lie on top of each other and intersect everywhere, right? So the answer's got to be all those points intersect, which is all real numbers. So my solution is all real numbers. Every x and y value, okay? Okay. Story problem time, huh? Real quick side note. Teague, about 6 years ago, your uncle was making port. And it was just like this problem. And I was able to help him out. We made a mighty good port because it was a matter of one solution being super strong, another solution being kind of weak, and you had to find the right amount of mixture. But I can't write a port mixture in the public school, can I? But it was pretty cool. I was actually able to use my math, and Don was like, okay, sweet. So, you know, and of course he's pretty good at math too, but it was like a snap for me. So we're going to do prairie dog food instead, okay? Not as interesting, but, you know, I'm not going to teach you how to make wine. Not a good idea. So, anyway. So a zookeeper needs to mix feed for prairie dogs so that the feed has the right amount of protein. Feed A has 12% protein and feed B has 5% protein. How many pounds of each should be used to get 100 pounds of feed at 8% protein? So think about it this way. So they've got 2 bags, right? One has got too much protein. The other doesn't have quite enough, so you got to mix them together, right? So if you want your animals to be healthy, you don't just throw it all in, mix it, and give it to them, right? We need an exact mixture. So let's see. First of all, we need 2 equations. So first, we need to have, let's let feed A and feed B. So we're going to go A plus B has to equal 100 pounds. Okay? So that's our pounds of feed. We're going to put so much of feed A plus so much of feed B to make a total of 100 pounds. Right? It might be 50-50, it might be 30-70, but whatever. We're only going to make 100 pounds. Agree with that? Now, Let's take our mixture. So the second equation's got to be a mixture one, right? So we're going to take 12%. So let's go 0.12a plus 5%, 0.05b has got to make an 8%, 0.08 of my 100 pounds, okay? So the second equation has to be the percentage of the mixture, okay? Well, if I simplify this a little bit, I'd have equation 1 is still a plus b equals 100. This one's question 1 is going to be 0.12a plus 0.05b equals 8. Okay? Decimals. Ugh. I don't care about decimals. I have a calculator, right? Don't scare me. Fractions, yeah, maybe. I can handle decimals. What do you think? Any ideas? Don't be afraid of decimals. Any ideas? Anybody out there? Let's multiply equation 1 by something. Let's multiply equation by something. What should we multiply equation 1 by? Come on, don't make Teague do all the work. What if you want to get rid of the b's? What would you multiply by? Negative 0.5. How's that going to help? It would cancel the b's. I'm going to have to deal with decimals, but they don't scare me. Okay, so equation 1. Let's rewrite equation 1. We have a negative 0.05a minus a 0.5b equals a negative 5, right? Equation 2 will leave the same. So equation 2 is a 0.12a plus a 0.5b equals 8. How am I doing? Okay, so then if I subtract these, I should have a 0.07a, right? 0.07a cancel, right? Equals 3, right? So if I divide, a is going to be 3 divided by 0.07. Use my calculator. So I've got 3 divided by 0.07, and I can answer about 42.85. Should we round it up to 43? 43? We'll be close, right? So let's go 43. So let's go 43 pounds of A, right? How many of B then should we have? Close. 47.
Oh, yeah.
Right? You're right.
I meant.
I know you meant that. 47 pounds of B. How do you think? What do you think? And of course, Teague was kind of fun because we got to do that with